For me, it's okay. I was able to.
I sent you a document afterwards about how the execution of the send takes place. Did you get that document?
Yes.
Yes.
Email.
And were you able to use it to answer the question? To integrate it into the answer of the question?
Yes.
I hope there was no problem. But you have submitted, right?
Yes, we have.
Yes.
Okay. For the other part, which is the connectionless, I don't think there's a problem with that one. Is there? It's pretty straightforward. There is no creation of connection and there's no termination. It is simply the data transfer phase that's there. So we expect the client to send the request and the server to respond with 5 segments, of which some of them get lost. I think they get lost and then they are not, because it's not a reliable protocol, they will not be retransmitted. So effectively, part of the file gets lost. Okay, so I hope there is no issue with that, and I hope that with that you know the difference between connectionless and connection-oriented and which application would benefit from it. Obviously, file transfer would not use connectionless because there's no point of transferring a file and some parts of the file can get lost. But something like a bank transaction would do. Maybe you send a request for balance and you get back the balance. Of course, if it gets lost, you can always request for balance again. But we'll talk about that in a short while because even that in itself is not the best form. So I have had these notes online for a while. I don't know if you've looked at them, but I want us to begin from the client server model. And please tell me if you have any issues with programming. If you have any issues with programming, you let me know. So I wanted to discuss the client server model a little bit more, just so that it's clear what it is. You know, it's a programming model. So when you are using this model, you're supposed to have a particular orientation, which I hope you have developed in the course of the time you have been programming. But let me just clarify a few issues. Now, these notes come from a section of your textbook of which I referred you to. I think it's chapter 2, if I'm not wrong. And so you can always go back there and read. I think chapter 3 we were to do it and we haven't done it yet. But I hope you have read. So this section that I'm covering, you can always go back to your notes and revisit it from your textbook, I mean. The last time I looked at it, I think I went through it very fast, but I feel there are certain things I want to bring out. So one of them is the distinction between service, interface, and protocol. I hope that distinction is clear. Having gone through networking, I'm sure you are aware that every layer had its own protocol, and every layer had its own interface, and every layer provided its own service. So you need to be able to distinguish those 3 concepts. Now, obviously, the protocol is a set of rules that layers would use. Not even layers, even if you have a client and a server, I said they have an application layer protocol. So whatever rules are governing their communication, that would be the protocol. And the interface would be the set of operations that you require to invoke to get a specific service. So for example, if you are providing the service of connection-oriented service, then you need to invoke certain operations. One is connect, then you need to invoke send and receive, and you can also invoke close. So the interface would provide those operations for you to get the connection-oriented service. So an interface basically implements a particular service, and a service may require several operations to implement it. For example, if you talk about the file service, there are several operations that implement the file service, like open, read, write, close. So those are, I'm sure there are more than 4, but those are 4 operations that implement what we call the file service. So please make sure that in your mind you're able to distinguish service and the interface that implements that service, where the interface provides you with the operations required to achieve that service. The banking service may have several operations: open account, close account, balance, credit, debit, but they're all operations to do with the banking service that is being provided. Okay, so unless somebody has a question on the difference, but I hope the difference between service and interface is clear, and the operations that are invoked. Now, another concept that I want to bring to your attention, and something you're actually familiar with, is the idea of layering. Now, of course, you've encountered layering when we were talking about networking. But layering is just a concept of how you arrange the components in your program. So it has been applied a lot within the networking domain, but it is not restricted to the networking domain only. Layering is basically just an architecture for organizing the components in your program. As I have already said, when you layer the components in your program, each component needs to have an interface and needs to have a certain protocol that it is using to communicate with a different peer component, if there is such a component that it's communicating, and it needs to be offering a specific service. So every component must have those properties. But what I'm saying is that layering is not restricted to networking. It can also be applied in the in general application programming. Now, if you look at an application that you are programming, if you think of like even the application that I gave you to program, where you had an online shop, if you think about it critically, it actually has different components. But maybe when you program it, you may not realize that you can actually separate those different components, each one of them being a specific layer. But let's start from the what we call the application interface. That program you have written, I have not looked at it, but I hope you've submitted. There must be a place where the user interacts with that system. So your program will provide an interface and the user will interact with the program via the interface. Now, what is the purpose of the interface? It is to communicate something to the user and for the user to respond. So for example, if it provides a menu and says the following are the things that you can do with this application, and we talked about a few of them, which was like purchase a book, order a book, pay for a book, search for a book, and so on. So that kind of menu may be offered to a user, and then the user will select whichever one they want. Maybe they want to order a book or they want to pay for a book or something like that. So the user will type what they want and the program will read exactly what the user's response. So there's that part of the application, which you may call the application layer. Not the application layer, the application interface layer or level. Now, once the user has determined what they want, assume they want to order a book, then your program now goes into the process of trying to order a book, whatever that process is. I'm not sure how you implemented your order, but maybe somebody can tell me how you implemented the ordering. Once a user says they want to order, then what do you do? What does your program do? Yes, can you have somebody? Craig?
I can go for an answer. Yeah. So when someone is ordering, they shall specify the title or the ISBN number to specify the book they're ordering, and then also specify the number of books they want to order. So let's say if someone wants to order the dictionary, they specify then to order the dictionary and then to order 5 dictionaries. So now what happens at the back? We have the file that stores the books. So we do a search operation for the dictionary and get the price. So we see the dictionary maybe is 1,000. So we do 1,000 times 5, we have 5,000. And there's a technique we're using to generate order numbers. Since we have all the existing order numbers, I just take the last generated order number and increase it by 1, and that will be the order number for this new person, and I store that in a file. So I store the new order, I store the new order number and the total amount. Then the message I return to the no, this is after the servers finish processing the response, it returns to the client. But it will return a very long string, but it has the delimiter stroke n to make it formatted. So there I include the book title, the unit price, the quantity, and the total price.
Okay, good. That is the way you have implemented your ordering. Basically, you say that you get the details of the book that the user wants to order, you search for that book, you find out if that book is available, and if it is available, you generate an order number. And then I think you say that you store the order number in a file, and then you return the response to the user. Did I get it right?
Yes.
Right. Okay. Now, by the way, I'm not even assuming that the program is client server. What I'm talking about could apply even to a program that has not been split into client and server. Because all I'm trying to say to let you know is that when you program, the program has several parts. Logically, it has several parts. I've already described the interface part where you probably present a menu to the user and ask them to select what they want. In other words, you interact with the user and the user interacts back to the program, right? That would be the interface part of your program. Now, depending on what the user selects, then you go into trying to understand what the user wants. In the case of order, Craig has told us exactly how he has implemented his program. But there is that part of, first of all, asking the user to provide details, finding out if the book even exists, and creating an order record for that particular user, and then storing that record. So whatever processing is required to process that order, that part of your application would be the application or the processing level or the processing part of your application, because it processes whatever the user wants processed. Whatever the user of the application wants processed, that would be the processing part of your application. And of course, that's dependent on the application, and it's dependent on what the user wants. If there are other options, like for example, if they had chosen search, that would have been a different process. Now, as part of processing, even from what Craig has said, as part of processing, you find that you may have to refer to some database or some data somewhere which is stored in your system. For example, in the case of Craig, he says that when processing the order, first they have to check data about books to find out if this book exists and how many copies, whether there are enough copies to serve this order. That tells you that there is a part of your program which has some data it's storing. Whether it's storing it in a file or a database, that's another issue. But there's some data that your program is storing, and from time to time you may need to access the data. So that would be the data level part of your program. The one that if asked, tell me how many copies of this dictionary you have, it will respond with some information. So logically, when we program, all I'm trying to say that logically, when we program, our program consists of these three parts. Now, in the case of distributed applications or network applications, you know that a program may exist on different machines. Different parts of the same program would exist on different machines. So for example, if your program has these three parts, you can decide to put the interface level on one machine, the processing level on a different machine, and the data level on a different machine. Then you would have distributed your application. But remember the first program I gave you to write, I just told you, just write the normal program the normal way you normally write, a monolithic program. I guess it would be called a monolithic program because everything is within the same program. But now if you split it into client server, then you have two parts. And again, you have to ask yourself, of these three parts, which part will be in the client part and which part will be in the server part? So you may choose to have the interface in the client and the processing and data level within the client, within the server. So these parts, they're always there. So depending on how you split your program, you may put the different parts of your program on different machines. You may even combine several parts into the same machine. For example, server may have both the processing and the data. But what I wanted us to agree on or to understand is that these different parts are in your program, whether or not you split it. So that's the first thing. Now, as I've said, of course, when you distribute your application, then it depends on how you place the different components. So in a distributed system, you have to think carefully. When you, in a distributed system and when you're writing a distributed application, you have to think carefully about those three parts of your program and where exactly you will place them. Now, remember that we have said that if you're using layering, obviously, if you split your program into several parts, you will be using layering. Because if you remember from what we said, the user interacts with the interface. Then the interface interacts with the processing part, which then begins to process what the user has requested. And when the processing part needs some data, it will then go to the data component. So you can see that that requires a kind of a layering structure, where one layer uses the services of another layer or makes requests to a lower layer. So obviously it requires a layering structure. And therefore, if you split your program into those three components, then each of those layers will have to have, you'll have to define what service is it offering, what interface is it providing. Those are two things you must clearly define. So you have to make that decision. Now, in the case where we are doing client and server programming, which is what we've been doing, then I think you will have to decide which of those components will go into the client and which of them will go into the server, and which interface they will provide. Now, remember that we took some time to define the interface for our server. Why? Because we said that when you're using layering, every layer must have an interface and must have a service which it is offering. So it's important that when you split your program, you define the interface for each layer. And you are clear about who is accessing that interface and how they need to access it. In the case of the application interface, we've said you'll display a menu to the user and the user will make a selection. But it should be clear how the user interacts with that particular part of your program. All right. So in a basic client-server model, I think I went through this at some point, but at that time I just wanted to clarify what a client-server model is. But let me go over it again. We say that a basic client-server model, the processing is divided into two parts or into two groups. There is a server and there is a client. And we say that a server is a process which implements a specific service. Now go back to the terms I just defined: service, interface, and protocol. So a server is a process, a running program, which implements a specific service. It may be a file service, it may be a database service, whatever service it is, but you have to know which service. So let me ask you, for the program that you have implemented, what service is your server implementing? How do you understand the service which your server is implementing? What would you call that service?
Service.
Okay. Did somebody offer to answer that question? If you are asked what service your server part is implementing, what would you say? Okay, Gregory? File service? A book ordering service. Does that capture? What about the payment? You're only talking about ordering. What about the payment part? Pardon? What service does a bookshop offer?
Commerce.
No. That's the interface. The service itself. What service would you say that the bookshop is offering? Hassan has written e-commerce service. Of course, it's an e-commerce service, but I think you could make it more specific, Hassan. I think, yeah, you're closer to the reality or the truth. But maybe you can make it a bit more specific. Roman, I feel that you are concentrating more on the different operations that have to do with the service, but I want you to summarize the service itself. Yeah, just something that captures everything that is done as part of trying to achieve something. What is it trying to achieve, right? Okay, a bookstore service. Well, I guess it depends on how somebody understands a bookstore service. I may understand it as just somewhere you store books. Textbook Center, yes. But what service does Textbook Center offer? Because Textbook Center is a bookshop. But if you are asked what service do they offer, what would you say? Because they offer a service.
Could it be
Okay. As long as whatever you say, you can clearly define it. But personally, I think it's a shopping service, some kind of a book shopping service. Because you go there to shop for books. Of course, I think Textbook Center offers more than books, yeah? So it's a bookshop, not only for books, but for many other things, stationery and so on. But the one that we are doing is just for books only. So it's some kind of a shopping service. It provides you with some kind of a shopping service for books. So when I say shopping, a shopping service, I guess you mean you know that you can go in there, look for the book you want, and if you want to buy it, come out with the book. So you can purchase a book. So by definition, you know that they must be able to store books, because how would you shop for a book if it's not stored? So definitely they would have some kind of storage where they store the book. And it would also imply, by implication, it would imply that there is a way to order or to say which book you want and to pay for it. Those are all included in shopping of anything you want to shop. You select it, you search through what is available, you select what you want, and then you pay for what you want. Those things are included in a shopping experience. So then that's why the interface would have things like search, and then when you select, you order, and then you pay for it. But more specifically, I think it's not just any shopping service, it's an online shopping service. Because remember, we said we are ordering, and once you pay for it, it is shipped to you. So it has to be an online shopping service for books. So whichever words you can use to capture that, it's just okay. So now you realize the difference between the service and the operations or the interface, how you interface with this service, because there are several things you may want to do. First, you search for books, you select the one you want, and then maybe you order for it, and then you pay for it. Of course, in any bookshop, it can be organized differently. So as I said, yeah, an online store service arena. Yeah, online bookshop service. Online bookshop service. I think that would be better. Store, when you just say store, I think gives me the impression of some kind of storage service. It doesn't bring in the idea of being able to purchase a book. Okay, but I hope the distinction is clear between service and the interface, how you interface with that service. So what we are saying is that a server is that program or process. It's actually a process, not a program, because you should know the distinction between a program and a process. A server is a process that implements a specific service. Whether it's a file service, a database service, a book shopping service, whatever, a banking service, any service. And a client is that process that requests a service from the server. That service is provided by the server so that whoever wants to be served in that way, whichever program wants to be served in that way, can request for the service. So the question is, how does it request for the service? Now that will be described by the interface provided by that service. So in the case of the shopping service, the book shopping service, it provides an interface like for several operations that are part of the whole process of shopping for a book. It provides an interface. It provides an interface for ordering a book, provides an interface for searching for a book and paying for a book. At the minimum, there could be more operations. So the client that is requesting for the service must know that interface. They must know the interface provided by that server, which is now a layer. Remember, you're talking about layering of application components. So between the client layer and the server layer, the client must know how to contact the server in order to get the service that the server is offering. Now, if your program is client server, in other words, the client is on one machine and the server is on a different machine, then the client must send a message to the server requesting for the service. And that message must conform to the interface provided by the server. Now, again, I'll ask, in the implementation of your program, what message does the client send to the server when they are ordering a book? Let me have somebody. Maybe not Craig, because Craig has already told us how they process an order. But now assume that the client and the server are on separate machines, or at least the program is split into two components. What message would be sent, or what message were you sending? First of all, before you give me an answer, let me say that if the application was not split and these, what are they called? The interface, each of the operations on the interface was implemented as a function, then obviously you just call that function in your program. You call the function to order, you call the function to search, you call the function to pay. So if the program was not split, the interface would just be provided as functions. And so the client would just make a function call. But now we assume that those functions have been moved to a different machine. And so you have to call the function from a remote machine. What message would you send? And I'm only focusing on the order. What message would you send to the server so that you can invoke that function that is on a remote machine? Okay. Let's have somebody. Aduma Tevin.
Let me attempt. So, in our case, assuming I'm the client and I want to send a message to the server to process an order, first of all, the client will invoke an order function which is basically a stub that mimics the function at the server. And so the format of the message will be much like Craig said. So in our case, it is how we formatted it was order, and then order, and then colon, and then now after colon, you can either now put the ISBN, which would be a string of numbers, or the title of the book, which is now a string of characters. So that is packaged. I assume at the, I can't remember well, but I think it was at the application level. As, that is now where the order function, the stub, is at the client, and then that is now what is passed through as the message down through the network. And once it arrives at the server unpackages the message, and obviously now at the server we already have our functions. Now the skeletons that are mimicking the stubs from the other side. So the server will unpackage the message and see order colon. So the first string order, now that's a function that it searches for within its catalog of functions. After that, it goes through the colon, and then now it checks the set of strings that it has been provided with after the colon, whether it's a set of numbers or a set of mixed characters, and does a search. So the performance for us was either you search by string or by number, and that we did not discriminate. So it runs a search on both the ISBN and a search on the title, and if it finds the ISBN or the title, it returns, just like Craig says, it returns the book that was ordered. If it doesn't exist, there's an error message or something along those lines.
Okay, I'm following you to an extent. I'm following you, and I don't know whether there's a stub on the server, but I've followed you to some extent.
The stub is on the client, and the server, I think we're calling it the skeleton. I don't remember well the term.
Okay, so I want to follow what you're saying. Okay, first of all, let me just talk about the server, this server part. Remember, we have said that if there was no splitting of the program, this function would be on the client side. So the function we are talking about specifically is order. Can you remind me what were the arguments for order?
The
Remember the
title of the
arguments we gave for order? You remember?
not clear. I just remember the ISBN or the title of the book.
And there was something about number of books you're ordering. Who remembers what was in the order? The order was Shasta, if I remember. There was Shasta for title and Shasta for ISBN. And then the integer, the number of books. Number of books, something like that. Right? Tevin?
Yes.
So now what we have simply done is we have moved this function to a different machine. Client side, and remember we are doing client server programming. We are using sockets. So I'm actually even surprised, Tevin, that you brought in the issue of stub. Because when you start you're talking about the stub, you're now talking about distributed programming. We are talking about socket programming. But anyway, at least you are aware of the stub because I think you've done the distributed systems course. So that's okay. But I think right now you should realize we are doing socket programming. So on the client side, what does the client do? And what I'm really trying to drive at here is that the client needs to send a message in order to access this function called order. So it needs to send a message to the server so that the server can be able to execute this function on a different machine. So what message does the client send? Remember that in this client, they have interacted with the user. So they have obtained details, order details from user. I assume they have obtained some order details from the user. And now they need to do what? To formulate a message. And then they send the message. I'm sure you've seen those things in your what did you call it? The algorithm, conceptual algorithm. So you formulate a message and then you send the message. Because in socket programming, you're dealing with messages. So my question is, this message that was formulated, how did it look like? I think that's really the question I'm asking. Your program formulated a message to send to the server. What was the content of that message? So Tevin, just take me through the message content again, the one you said you sent.
So initially I said the client will package a long string, and the first part of the string will be the word order.
Okay. Order.
And then it will be delimited by a comma, a colon. And then, so in our case, we did not do Chester. I've just realized we only take one string, the first initial string, which is either a set of numbers for the ISBN or a set of mixed characters, and that will now do a search for the title.
Oh, okay. I think it was the payment that had a Chester.
Yeah, I think so.
Okay, so order probably, I said you order. No, I said you order by specifying the title and the ISBN. I thought I did that, but anyway, in your case you didn't. So what did you have?
So, like I said, after the colon, we have a set of characters. So the characters could either be numbers, and that will be decided. We use the C function to check if all of the characters after the colon are either numbers or they are mixed.
Okay, give me an example of a number.
Well, let's say the ISBN is 164 250 250.
164 250.
Yeah.
Okay.
And say it ends with 84.
84. So that's an ISBN for a book, right?
For example, yes.
Yeah. Okay. And then?
So after that, when this message now is packaged, I'm in class. Yeah. Naongea na mwalimu just for a second. So
Hey, David. Okay.
yeah, sorry. Yeah, sorry. So this is now at the application level. The message is packaged as after the client now. This is the details that they're obtained. Now the 164.250.84, and they've hit the order command on the interface.
Okay.
So the message
I
is
just want you to stick with the message itself. So this is all that is in your message to the server.
currently, yes. Yeah.
Okay. So that's what's in the message in your case for the server. Remember that the server will receive this message.
Yeah.
So in your server program, there'll be a receive. So it will receive this message.
Yeah.
And then what does it do? I think it processes the message. Yeah?
Yes.
Process message. So how does it process this message to understand what the user is saying?
So it splits it by the delimiter, which is the colon.
Mm-hmm.
And it takes the first part of the message. So if it's delimited by the colon, the first part of the message is the word order.
Mm-hmm.
And so what we did is we used a hash map.
You used a
hash map to check whether now the word the first word now is a set of our functions, which it already is, since we already have the order function at the server.
So if the word that you obtained is equal to
a function,
order,
yes,
then you call the order function.
Yes.
Okay.
And the argument is now the next part after the delimiter,
which would be the ISBN.
Yes.
Okay. I just want you to just go up to there because I'm interested in the message. So the message, as you have put it, assume therefore that your order has only one chapter, but you even don't have the number of books in your case. How come? In the message, how will the server know how many of those books you want?
Yeah, I have to redo that.
You're redoing and you already submitted. Yeah, but what I'm driving at is the message must reflect the message must reflect the actual operation. Yes. This operation, as it is in my case, I am expecting that you'll have the title of the book. So you'll have the function that you want to execute. You will have the title of the book that you want to order and its ISBN. So those will be two different items in your message, or two different parts of your message. And then you'll have the number of books. So that now when the message is received by the server processes that message, should be able to extract from that message 4 things. 1, the name of the service. Secondly, they should be able to extract the title of the book. They should be able to extract the ISBN of the book. And they should be able to extract from that message the number of those books you want to order.
Yeah.
Now, I'm not sure why you did your program that way, Tevin, because that already tells me that you didn't follow the instructions. You didn't follow the interface I sent you. You followed another one of your own. Is that it?
As a group, no, but personally, this is what I was doing on the side. But as a group, I think we used your entire interface.
Oh, so this is just your own?
Yeah, when I was testing by myself initially.
But you actually wrote the program? Because I'm asking you to recollect the program that you were writing. The one you were writing, but anyway, it's okay. So all I want to say is that the message that is sent by the client, remember we are talking about the interface, the service, the protocol. right? So basically, we have said the server is offering some kind of book shopping service, but in order to shop for the book, there are several things you can do, like order, search, and so on. So we've zeroed in on order, and I therefore asked, so if the client wants to access any service from the server, they send the server a message. And it means that the client must be fully aware of the interface provided by the server, so that whatever message they send conforms to that interface. So in this particular interface, I believe that what you would send, if you have to go by that interface, then I believe you would have order, and then you would have title, the title of the book, whatever it is, whatever that title of the book is. You'd have a delimiter, whatever it is, maybe full colon, and then you'd have the ISBN, and then you would have the number of books, maybe 5. So your message should contain at least those 4 items. So when you're formulating your message, you make sure that you have all those 4 items in your message. And the assumption is that once you send that message, the server understands that message to mean that you want to order a book with that title and with that ISBN, and you want to order 5 of them. And now that is the application layer protocol. The application layer protocol demands that when you send a message, you send it in this format. Because if you send it in this format, we will understand what it means. The server will understand what you're trying to say. Anyway, my focus wasn't on the program. My focus is on what I'm trying to communicate in terms of client-server model. So let me just go back to the notes. So I was trying to define the difference between a client and a server. So a server is that process that implements a specific service and has an interface for that service. In our case, it's implementing a shopping service for books, and it has an interface with several operations, including order. Now, a client is a process that requests for a service from the server by sending it a request message. And so I had stopped there to find out what kind of a request would you send? Or what kind of a message would you send? In the case of order, you would send an order request, and the message would contain those 4 items. And subsequently, it would wait for the server to reply. Now, in your case, what was the server replying? Let's assume your order is processed and it's successful. What would be the reply from the server? Aduma, in your group, what was the reply from the server?
So assuming it's a successful order request, so we also have a file that keeps tracks of the orders. So it increments based on the number of orders in the file. And that now will be the order ID for that particular successful order. So it returns details of the order packaged to the user. So the message in this sense would be, so if it's a successful order, the message would return, the initial text in the message would be so to represent a successful message, it would write SUCC _ order.
What does SUCC mean?
Success.
Oh, that it was successful. Okay.
Yeah.
So I'll separate this into request message and reply message.
Okay.
Okay, so that's reply message. So what would be your reply message? You said it sends some string that has that word to mean
Yeah, and
success.
underscore. Yeah,
Underscore what?
order.
Order. Okay. Order. Okay.
And then colon again as the delimiter.
Mm-hmm.
And then now we start with the order ID. We were assuming all the arguments are already arranged. So it will not write order ID as a string, but it will write now the actual number.
Okay. So let me assume the order is 234.
Okay.
Then?
And then the comma
Mm-hmm.
for delimiting now the return values. So 234 is the order ID. And then now we were returning the title. We were not returning the ISBN.
You're returning the
Maybe,
title? Mm-hmm.
yeah, the title. And then the amount, the price of the book.
Okay. Mm-hmm. The price of a single book. In your case, you don't even seem to have been ordering more than one book, but let's assume I ordered 5, so it will give me the cost of purchasing 5 books. Okay.
Yeah.
Then?
I think this was it for now, and from here now we have to trigger payment. But now what will trigger payment is the SAC order.
No, Aduma. I think you're confusing something here. I'm not sure why, but I get the feeling that there's something you're confusing.
Okay.
Either you're not listening to what I'm asking you carefully, but you need to conceptually separate what is going on in your program. Remember the first time I asked you, what is the message?
Yeah.
You said very many things, including the message itself, but you actually gave me quite a number of things like the stubs and so on. And in my mind, I was wondering why you were focusing on those issues which I did not ask you for. I only asked you for the message that is sent by the client and what is the content of that message. And then you said many other things that are not relevant to answer that question. Right now, I've asked you what is in the reply message. You have given me what is in the reply message. And I think I asked you then what happens. And I feel that you are telling me other things that are not part of that request that I'm making. But first, let me finish this part of the client. The client sent the message and then receives a reply. In your program, there should be a receive of reply.
Yeah.
Then it will process that reply. It will process the reply. So how does it process your reply and what does it do with it in your case?
So that's what I was saying. After it receives the message that we've written, so the first part we were using now again the delimiter, the first part of the string stack order. So it already realized that the server has found the book, done a calculation, and returned my order ID, the book title, and the total cost. So from there, sorry.
Then what does it do?
Oh, so since it's a successful order, it progresses now to prompt the user for payment based on the costs and the ordered ID, because that's the order we are focusing on.
Okay. Did we say that? What do you tell the user? Because there is the interface part of your program.
Yeah.
The user is, standing there waiting.
Yeah.
They had chosen order, and you've gone into your program. You've done all that, and a response has come. What does your program tell the user or display to the user? Does it display anything? Does it? Aduma, are you there? Or am I confusing you now? Okay, can I have somebody else? Because I am not sure whether there is a problem with understanding the program you are writing, but I'm trying to discuss it here so that in case you have not done it, you make sure that you do what is requested of you, because it then means that you will not, when I mark it, I will not understand what you're doing and I will not give you the appropriate marks. But let me go back a little bit. We have said that a program has an interface. So can somebody tell me what was in the interface part of their program? What was in the interface of your program? Can somebody tell me? What did it look like? Or what was the content? Are you there? Or am I talking to myself? Roman, are you there? Why are you all so quiet? Nyamao Gregory?
I'm there. I'm there.
Okay. I thought I was disconnected. I thought I was disconnected, but please, can you tell me? Is this what you did or you did something else? Because now I'm getting worried. Is this how you wrote your program or you did something totally different? Mm-hmm. Mm-hmm. Okay, so I imagine when the user begins to run this program, they'll see some kind of interface that allows them to order, to search. I don't know what exactly you tell the user. Do you tell them this is an online bookshop and these are the operations that, or these are the things you can do within this application? I don't know really what you say, but there is something to do with payment and maybe there's something to do with exit, I don't know. But you provide an interface for the user, right? Is that correct? Yeah. Okay, so that would be one, for example, and this would be two, right? Something like that. So in the case of order, maybe they would enter one or two, whichever is in your program, but let's assume it is one. So they would enter one, and then? Mm-hmm. Yeah. Mm-hmm. Yeah. 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 Mm-hmm. Yeah. Mm-hmm. Mm-hmm. Okay. Where does he get them from? Okay. So your message if I am to look at the one that Aduma was talking about, your message would consist of order would be the number, not the text order. It would be a number followed by a title, followed by an ISBN, and followed by the number of books. Okay. And the reply would be? Mm-hmm. 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 Okay. All right. All right. And remember, I'd said the application layer protocol can be different for the different groups. So from what Aduma said and what you said, obviously you had different protocols, but they achieve the same thing. So once the message has come back, obviously it will be received and it will be processed. So we had stopped here with Aduma. So in your case, when you process the reply, how exactly do you go about the processing? Mm-hmm. 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 Okay. 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 But you actually display something to the user when the order results come back. However, I would like to just comment. I wonder why you are sending back the ISBN and the title, because remember, you have just read them. You just read them from the user, and so you have those details. So maybe you may need to consider that aspect of what is sent back, because you already have that information. It may be an overhead to send it again, but it does no harm generally, of course. But in terms of bandwidth, you need to think about it. Okay, fair enough. Fair enough. And so the user can even choose to exit, isn't it? After ordering, they can choose to exit. Yeah, you can choose to exit, and when they come back again, they can now give the order number for actually that order they had done earlier, right? Isn't it? Yeah. Okay. So let me just go back to this program here. I know my time is almost up. It's actually up, I think, but let me go back to this. Okay, so you know what a server does, and you know what a client does. It sends a request and receives a reply. And from what we have seen, you need to format the request according to the function that is going to be executed on the other side, or the operation that the server needs to do, in a way that the server can interpret that message correctly and do the correct thing and send a reply. So that's why it's referred to as a request reply type of protocol. The client always sends the request and the server sends back the reply. And it needs to be processed. Now, from what I have said, maybe I just want to, and maybe this is what I'll do and the rest we will do in the afternoon. I need to then go back to the, what do I call it? I need to skip to another set of slides here, very briefly. It's called types of servers in your notes. And I want to focus on this algorithm. From what we have said, I have put in red there the conceptual algorithm for the server. And I want you to note that the server processes a request when that message we have talked about is sent. Okay? No. This is for a different. This is for a different. It's not what I want to say. This is not the algorithm I'm looking for. Sorry. I think there's another algorithm. I just want to. I want you to understand those things I was saying that are part of the server and client algorithm. Okay, so let me just project this one. I hope it will give me what I want. Stop sharing this. Okay, I'll just do it for the iterative server. But I basically just want you to take note of these things I have put in red. From what we have just discussed, remember we have said that a message is sent to the server. The server needs to read that request or receive that request. So the read there is exactly means receive as well. And then the server needs to process the request. Process the request is what I think Roman and Duma was saying. Depending on the string that you have sent, the server needs to process that request and extract the different items from that particular string. So in the case we have discussed, you extract the order, the actual operation that the user wants to perform, which in this case is order. Then you extract the arguments of the order. In this case, there are 3 of them. There is the ISBN, the title, and the number of books. So in the order case, process request will include processing that string that has been sent. And then it will also include calling the order function with those parameters. It will mean calling the order function, executing the order function, and receiving a response from the order function. All that will be part of processing the request. So, for example, if in an exam you're given a question that says, write a program that shows how the server would process the request, then your program or part of the program will include all that. Having received the string, how exactly would your server go ahead to process that string? And how exactly, after understanding which operation the user is requesting for, how exactly would they execute or go ahead to execute what the user has requested? So if the question is about process request, you're expected to do only up to there. Assume you have received, so you show exactly what you have received, then go into processing that string, go into calling the function that the user wants to execute, and let the function return whatever it is supposed to return, or the answer to the request of the user. Then there is the formulator response. Formulator response would be now packing the message in, packing the response into a message, constructing a message like the ones we have seen. Okay? In the case of the reply, Aduma said they put their a text a word success, followed by title, followed by ISBN, and followed by the cost. I think Roman said the same thing as well. So packing those things into a message in order to send them to the client. So when you are dealing with the programming part, we only talked about the different socket primitives like connect, bind, so all those kind of things, listen, and so on. But now when you're writing the program and client and server are communicating, you need to take into account these things that are in red. And I think I mentioned that in your program, you need to separate them and actually, what do you say, comment, put appropriate comments. So for example, before process, I would expect that you would put a comment that this part includes processing a comment, processing the request. Then you would go into how the actual processing does up to the time when the processing ends. Then the next part of your program would include formulate. Now you're formulating the response, how you take the response of the server and put it in a message. All the instructions or the code required to do that. And then you would send the reply back to the client. So I hope you read these conceptual algorithms and that your programs are in accordance with these conceptual algorithms. Now, of course, in an exam situation, it will be difficult to give you a whole program to write in an exam. So maybe the parts of the program you're supposed to write will just include specifics like formulate a response, process a request, read a request, those type of things. So you need to be familiar with the actual conceptual algorithms because it gives you a logical sequence of what goes on within the program. But now when you come to writing the program, you need to expand each of those items in your conceptual algorithm, which I believe and hope you have already done. All right, any questions? Any question? Is that what you did? Roman, that's what you did. Okay. What about the others? Mutuku, is that what you did?
Yes, for us that's what we did. Yes, and we did not have a problem with that. For us, the programming challenge is okay.
Say that again.
I'm saying for us, the programming assignments are not an issue.
You're not hard.
Yes.
Okay, that's good. Okay, so in the afternoon, I want to continue with the client server model. And there are a few things I still need to highlight. And then I want to, there are many things I want to highlight. I want to go through the different slides that are in your network programming part and highlight specific things which I think are important. Okay, so we'll have our next class at 2. I think I've run out of time, far beyond time. Or when are we supposed to finish? 10:45, right?
Yes, five
Yes.
or 6 minutes.
So I've gone beyond by 6 minutes. Okay, thank you so much. Let's meet at 2 o'clock.